My name is Christos D. Papageorgiou. I am a professor of National Technical University of Athens, and what you are about to see in the next video is a small experimental solar chimney power plant constructed at a suitable piece of land near Compotades outside Lamia of Greece. In this small experimental solar chimney power plant, the possibility of increasing the efficiency of solar chimney technology through a proper arrangement and design of its components is examined.
Γι' αυτό πέφτει ο κόφτης.
Να σημειώσει κανένα συσκευές εδώ, δηλαδή, τις προδιαγράφες, την εταιρεία, δε.
Ποια?
Over the last 10 years, Professor Dr. Engineering Christos Papageorgiou was methodically involved in research and development of the solar chimney technology, because he strongly believes that it may come out the major solar technology for mass production of low-cost electricity. His theoretical study on solar chimney technology started in 2003 and resulted in a number of international patents and a set of publications in international conferences and journals. The results of his research were presented in a separate chapter of an e-book on solar technology. His experimental study of solar chimney technology began in 2010 when he raised a small experimental floating solar chimney. The small experimental power plant that was shown in the previous video, shown also in the adjacent photo, is his next experimental step in which the possibility of increasing the efficiency of solar chimney technology through a proper arrangement and design of its components is examined. The results of this experimental study were satisfactory, and we are now in the position to build solar chimney power plants with lower solar chimneys and smaller area greenhouses than initially was estimated. The typical solar chimney power plant consists of two parts. 1. A solar air updrafting system that, using solar energy, creates a constantly moving warm air stream, artificial wind. This system is consisting of a special solar collector, the greenhouse, and a tall cylindrical structure, the solar chimney, connected to the greenhouse. 2. An electricity generating power system consisting of a set of air turbines that rotate forced by the previous warm air streams and generating electricity by means of the electric generators that are engaged to them, as special wind turbines. The solar irradiation passing through the transparent roof of the greenhouse warms the ground beneath the greenhouse, while its transparent roof blocks the thermal radiation of the ground and decreases the thermal losses due to the air convection. Thus, the air temperature inside the greenhouse is increasing and becomes lighter than the ambient air. As a result, the warm air is pushed to escape through the solar chimney to the upper atmosphere. The escaping warm air is continuously replaced by fresh ambient air entering into the greenhouse from its open entrance. So the warm stream of air is moving constantly as far as the greenhouse ground is warmer than the ambient air, and this phenomenon can last several hours after the sunset. The turbines can be placed anywhere in the path of the warm air stream, generated by the system greenhouse solar chimney, and as they are forced to rotate by this stream, they are generating electricity through their engaged electric generators. It can be shown that the rating electrical power of the solar chimney power plant and its annual electricity production is proportional to the height of solar chimney and the surface area of the greenhouse. The proportionality factor is the performance efficiency of the power plant and depends, among other things, on the geometry, the arrangement and the size of the components of the solar chimney power plant. The solar chimney is a light metal structure with a height of 25 meters and a diameter of 2.5 meters. This metal structure was designed and its construction was supervised by the architect-engineer Dimitrios Kores, who is a warm supporter of the solar chimney technology. The roof of the greenhouse of the small experimental plant as a temporary structure was made of a clear plastic and has a surface area of 1,020,000 square meters, about 1 out of 4 acres. The material of the transparent roof of an ordinary greenhouse should be of crystal clear glass, low iron float glass. At the entrance of the greenhouse, a small turbine of 1.12 meters diameter was placed. This turbine rotates continuously, forced by the incoming stream of ambient air. This stream of air becomes warmer as moving inside the greenhouse and is updrafted through the solar chimney to upper layers of the atmosphere. The measurements in the power plant showed that the produced electricity by its turbine is higher than the kinetic energy of the rising column of air inside the chimney when the turbine forced to stop. Thus, the results have been considered as very satisfactory. The experimented power plant was designed as part of the research effort to improve the performance efficiency of solar chimney power plants. His PhD candidate, Mr. Michael Psalidas, has contributed in the study, design and experiment of the small solar chimney plant. Our next step on the development of solar chimney technology is the construction of a solar chimney power plant with a solar chimney of 50 to 60 meters height and 5 to 6 meters diameter, connected to a specific solar collector, glass-roofed, with a covered area of 5,000 to 6,000 square meters and equipped with a special set of wind turbine generators with a total power 10 to 25 kilowatts. The results up to now are satisfactory, and with the aid of the upcoming experiments and measurements of the intermediate power plant of 10 to 25 kilowatts, the solar chimney technology may have direct production cost of electricity lower than the direct production cost of the other two major solar technologies, meaning photovoltaic, PV, and solar concentrated power plants, CSP. Due to the fact that the solar chimney technology uses simple materials, mainly glass and steel, has negligible maintenance cost and long life, despite its needs for more area per produced kilowatt-hours, will prevail over other solar technologies, especially in countries with abundant solar energy and unlimited deserted territories. The ultimate goal of the R&D is to design and construct a prototype solar chimney power plant of rating power about 1 megawatt hour, generating not less than 3,000 megawatt hours per year. The construction of the prototype solar chimney power plant will permit the construction of huge electricity generating solar farms consisting of hundreds of adjacent prototype solar chimney power plants in deserted landfills. Favorable countries for the implementation of the solar chimney technology are USA, Nevada, Utah, Arizona, New Mexico, Texas, etc., United Arab Emirates, Qatar, India, Australia, South Africa. Soon, we will be in the position to send a business proposal to potential investors in these areas for cooperation.